Hello friends, welcome back to Graph Theory Lectures. This is our lecture number 5 and in this lecture we are going to study isomorphism. Okay, so first of all we will see the definition and then we will see some example of isomorphic graph. So first let two graphs G1 equal to V1, E1 and G2 equal to V2, E2 graph. Then we will say graph G1 and G2 are isomorphic if there exists a map phi from set of vertices of G1 to set of vertices of G2 such that phi is bijective and another map theta from E1 to E2 such that theta is bijective. That means these both maps should be 1 1 and onto. Okay, and one another condition that if AB belongs to V1, then phi of A and phi of B are adjacent if and only if A and B are adjacent. Okay, so this is the definition of isomorphism. So if these condition holds, then we will say that two graphs are isomorphic graphs. Okay, so now let's see some example of isomorphic graph. So let's take first example. Second simple example. This is name this vertices A, B, C. Let this be graph G1 and this be graph G2 whose vertices are D, E, F. So you can see if I will map A to D, B to E and C to F, then there will be one-to-one correspondence between set of vertices of graph G1 and graph G2. Also, if I will name this as E1, this E2 is E1 prime and E2 prime, then we can map E1 to E1 prime and E2 to E2 prime, right? This is one-to-one and onto. Also, we can see here that A and B are adjacent in graph G1 and phi of A that is D and phi of B that is E are also adjacent in graph G2. Okay, so therefore G1 and G2 both graphs are isomorphic graphs from our definition. Now let's see another example. Example number 2, that is, let's take these four vertices as A, B, C, D. Let's name this graph G1 and let's, let's make another graph. So E, F, G, H. Let's name this graph G2. Okay, so now if we map A to E, B to G, and C to F, and D to H, then we can see there is one-to-one correspondence between set of vertices of graph G1 and set of vertices of graph G2. And similarly, if I will map this edge to this edge to this edge, and this edge to this edge, then there will be one-to-one and onto between the set of edges of graph G1 and graph G2. Okay. So again from our definition, these two graphs are isomorphic graphs. Okay. So now let's see some common sense to identify whether these two graphs are isomorphic or not. Okay. So first of all, we will see that these two maps, phi and theta, are bijective maps. Okay. That tells us that set the cardinality of V1 and cardinality of V2 should be equal. That means the number of elements in set V1 and number of elements in set V2 should be equal. Also, at the same time, cardinality of E1 and E2 should be same. Okay. So first of all, we will check these two conditions. If these two conditions doesn't hold, that means obviously that graph will not be isomorphic graph. Okay. So if these two condition holds, then we will check the further condition, that whether a and b are adjacent and phi of a and phi of b are adjacent or not. Okay, then we will identify the graph is isomorphic or not. Okay, so I hope you understand this, and thank you for watching this video.